Hello, my name is Daniel Garcia with the Breeze Home 5.0 agent team. In this video, we'll be going over Docker Compose, how to start and stop services, how volumes work, how to delete them and see where they are and what's inside them. As you can see, I'm at the prompt for this shell for the Vagrant VM, and I'm just going to cd to the Breeze Home dev directory that contains our Docker Compose.yaml. And we'll get to the Docker Compose.yaml in a moment, but let's start by looking at the Docker Compose command line. And so, of course, we can look at the man page like all the other commands, and right away we can see that the syntax here is Docker Compose, some options, a subcommand, and then some arguments. You can see those subcommands listed here. And so, important thing to note is that Docker Compose will be looking for a Docker Compose.yaml file in the current directory by default. If you want to override that, you can use the -- file argument. And so the first thing you might want to do is to start the services. We can just do that with Docker Compose up -d. And you'll see that if we try to run that, we'll get a permission error. That's because you need to be in the Docker group or root in order to interact with the Docker daemon. And so we'll just use sudo here to do Docker Compose up -d. And just a note, you should not add yourself to the Docker group. There's some pretty easy privilege escalation to root from that. I'll leave that as an exercise for the audience. But don't add yourself to the Docker group. And so you can see we've brought up the services. And so if I do a Docker Compose PS, we can see we have several containers here. We have the backend API, Memcached, Redis, the Nginx container, which is this web, the chat backend, the Postgres database, the desktop frontend, and pgadmin. We can see the command being used to start the container, its current state, as well as what ports. And so we can see here the API, for example, is listening on port 8080. And that's being forwarded to 8080 in the container. So we're listening to 8080 on the host and then forwarding that to 8080 on the container, which is where the API is listening. And so you can see Docker Compose up ran pretty fast. That's because I've run it before. But oftentimes you'll want to rebuild a container. So in this case, we'll just use Docker Compose build API to just rebuild only the API container. We can see it running through all of the commands in the Docker file, and you can see we get an error. And so something has gone wrong in the Docker file. And so if we want to look at those logs, for example, we can use Docker Compose logs API. You see we get a lot of data. We'll just pipe that to a pager. And so this is always useful whenever you're having an issue in a container. Definitely check out the logs. It's a good first place to start. Now I happen to know what the issue is for this. And so we'll go to our Breeze API Django repo. And we can see here in this repo we have a Docker file. And so this is the Docker file that's causing our issues when we do a Docker Compose up. So I'll just edit that Docker file, and I'm going to use Emacs here, but feel free to use VI or Nano or whatever you're comfortable with. This is also in the shared folder, so if you'd prefer to use something on your host, you can do that as well. So when we open up this Docker file, we're going to see several directives. The first one being this from, and this is the base image that we're going to build our image from. And so the from directive takes one argument, and this is the image on Docker Hub, and then a tag for that image. So this is going to be a Python image running Python 3.5, and I happen to know that this is going to be Debian. So we're going to be running a version a Debian inside of our container, even though our host machine is running Ubuntu. And so the next directive is going to be env, and we're going to set this environment variable. And so this environment variable will be set in the context that all the following commands below it will be run. We then have the maintainer, which is just some metadata on this image. Then we get to the meat of the Docker file. So first thing we're going to see is this run directive, and so we're going to update the package cache, and then we're going to install several packages. And you'll notice this -y argument, and this allows apt-get to install packages non-interactively, which is important because nobody's running these commands, right? So it needs to be able to run without requiring user input. So next we'll make a directory. -b here just means make parent directories as well. So ensure that this path exists. And then we're going to make that our working directory. So this is analogous to a cd to change directory in the shell. Next we'll actually copy over the source code. And this is a common idiom that you'll see in Docker files, where we're going to copy over first only the requirements.txt file. We're going to install our dependencies, and then we're going to copy the rest of the source code. And so let's go through this one line at a time. We have the copy command, which on the left is going to take a path on the host, in this case requirements.txt in the current directory, and it's going to copy that to the path on the right. So in this case, the directory we made, usr/src/app. Next, we'll upgrade pip, and then we'll install our dependencies from the requirements.txt. We'll then copy the rest of the source into that file. And so the reasoning here, the reason why we're copying over only the requirements.txt and installing dependencies instead of just copying this all in one copy directive and then installing the dependencies is because if we do it this way, Docker is actually smart enough to know what has changed in your container when you rebuild it. So for example, each of these run command is going to be a separate layer in the image, a file system layer. And so by setting it up this way, if we've changed our source code, but we haven't changed our dependencies, our requirements.txt, then we won't have to rerun these parts of this image when we rebuild. We'll simply take this part of the image that we already have, and we'll then copy the new version of the source and execute the container. So this ends up being a lot faster. Now if we'd copied all the source directly and then installed our dependencies, then even changes that didn't affect dependencies in the source would trigger installing the dependencies all over again. So this is a time saver. And so getting back to why we came here, we see the issue here is this libgdal1, which is a transitional name. You can Google for the specifics of the issue, but suffice to say that removing that one will fix our issues. We'll just save that file. I'll go back to our Breeze Home Dev directory with our Docker Compose YAML, and I'll just rebuild only the API container this time. And see, if you were quick, you could see that we actually didn't run the layers above that apt-get install again because they haven't changed. So we were able to use the cache to get the image up to that point in the Docker file, and then from there we'll execute the Docker file. And as you can see, everything's going smoothly. We're not getting the error we were getting before. And so you can see we've rebuilt the API container now. And so if we look at the running containers, we can see the API server is up. We can also check the logs for the API with the log subcommand. We can see gunicorn started. seems to be working properly. And so another thing you may want to do is actually get a shell on our container. And so these containers aren't running anything like SSH or anything like that, so we won't be able to log into them that way. However, we can just start a process in the container, and Docker Compose will hook or Docker rather will hook up our standard input and output to the standard input and output of that process inside that container. And so to do that, we just use sudo docker exec -it, and we give it the name of the container and then the process we'd like to start. So here we'd like to run the bash process on the API container. I just hit enter. And as you can see, I have a shell inside of the API container. I'm in the /usr/src/app directory, which was the last working directory set in the Docker file, and I'm the root user. And so you can see where we have all of the source that we copied over in that Docker file available to us. And so we can also run any of the commands that we might need to run development. So for example, we might install a new dependency. So in this case, I'll just install term color. It lets you print with color to the terminal using ANSI escapes. And so now we've installed a new package, and then I can start writing code using the term color library. But we're going to have a problem in that when we go to deploy, our requirements.txt isn't going to be set. So we're definitely going to want to create that. So let's just create a new requirements.txt, just pip freeze. And so we're going to want to get that file out of the container. So just exit, and so if I can do just look at the running containers here. And so what we can do is just do a sudo docker cp, and then we're going to want to the name of the container and the path. So in our case, usr/src/app/requirements.txt, and we're going to copy it to this directory, and we're going to call it backup requirements here. And so we open up that backup requirements file. We can see that we've gotten that requirements file from the container, and then includes term color. And so this is useful also in production when you want to get a file out of a container that's been running. We'll also want to know how to bring the services down. So to do that, we just use docker compose down. And this will bring down all of our services. We can see them going down one by one. And now if we do docker compose ps, you should see no containers running. And so we'll just bring that back up. And you can see we don't have to rebuild any of the images because Docker Compose is smart enough to tell what's changed. And so we just need to create these containers from their images. And we now have our running containers. So now that we've looked at the Docker Compose command line interface, we should probably look at the docker compose.yaml file that's controlling all of this. So we'll just open that up. And so first we can see this version at the top, and so there's a few different versions of the docker compose.yaml file depending on the version of Docker Compose that you're using. And so it's important that you pay attention to what version when you're reading a docker compose.yaml file. And then we can see the next directive here is a services block, and this is going to define each of our containers. And we can see we have a block. It starts with a name of the container for each of our containers. And then our last top level directive here is going to be these volumes. You can see there's a volume name and then a driver. In this case, all the drivers are local. Go over the API service here. And so you can see first we have this build directive. So it's going to say we're going to use this directory, this Breeze API Django directory, to build our image. And so by default, it's just going to go to this directory. It's going to look for a Docker file named Docker file. We have this restart directive saying that we always want to restart this container should it ever not be up. The container name, again, we're going to set to API. We'll set a few environment variables, and we'll set an env file, which again just has more environment variables that'll be set inside the container when it's run. We'll be forwarding ports 8080 to port 8080 on the host. And then we can see on this container we have several volumes here. And so most of these you can see we're taking a volume that we've declared in the volumes block at the bottom, and we're mounting it to a specific path inside the container, except for this one. So in this case, instead of creating a volume and letting Docker Compose handle that volume, we're just going to take this path here, which in this case is going to be the backup directory in Breeze Home dev. This is the current directory / backup. And we're going to take that directory and we're just going to mount it to /usr/src/app/backup inside the container. And so again, this is going to give us the same kind of persistence that we would using a volume. We're just going to be hard coding the path that goes to instead of having Docker Compose handle our volumes. This also has the benefit that if we were to delete all of the Docker Compose volumes, we wouldn't delete the backup. So the backup would remain. Next, we'll set some links. And so this is a Docker Compose way of saying that these two services are going to be communicating with each other. So we just give the name of the container. And we can also give a dependency. So say that the DB should be up before we do the API. And then we're going to pass this command. And you can see we're going to call this shell script that's part of our repo. And we're going to pass it these arguments. And we're going to hit our entry point. And so you can see the rest of the service follow along these lines. And this is very similar to what you're going to see in production. If you'd like to see the Docker Compose file used in production, you can look at the Breeze deploy repo. Note though that that's going to have a lot more containers having to do with Breeze infrastructure, not necessarily related to the application. And so if we want to see our volumes, we can just do sudo docu volume ls. You can see we have some name volumes here, but these are the ones we care about. And so if we wanted to find out where on the file system these volumes actually are, we can use inspect, and we'll just take the name of our, let's say, Postgres data. We'll take the name of our volume here, and we can see a bunch of metadata. What we care about here is this mount point. And so if I do a directory listing of what's in that volume, we can see the following files. And so if we were to do docker exec in the database, we should data, and we can see we have the same files that we were seeing in this other in the volume on the host. And so that's how you can find out where the data itself actually is for a volume. Another thing that you may want to do is delete what's in the volume. So we just do a Docker compose up, down dash V. This is going to include volumes. So a long version there. And so this is much like Docker compose down, except we're also going to remove all the volumes. So whereas we were using the volumes for persistence across these different container builds, we're going to lose all that persistence by doing a down dash volume. So you want to be very careful when you're doing this, especially if you're on the production system. You almost certainly do not want to do this. And so if I do a Docker compose up dash D, we can then rebuild, and we're also going to recreate those volumes. And so you can see these volumes being recreated. And so if we go to this, let's just go to the Breeze API Django. And so let's take a look at the entry point here. If we look at the Docker file again, you can see a command being set. And so this is the command that's going to be run this shell script, which I don't know if this is technically an entry point, but that's what they're calling it. So let's take a look at the entry point.sh. And you can see this starts the API container. So the first thing it's going to do when it comes up is we're going to migrate. So when this container comes up, it's going to look for any migrations. It's going to connect to the database, look for migrations, and see if there's any new migrations that need to be applied. We see a collect static. So if you're used to using Django in development, this will be a little bit different. In production, Django does not serve static files, or in this case, JUnicorn does not serve static files. Instead, those static files are going to be served by Nginx. And so though there's a volume that gets mounted to both the API and the Nginx container, and so that allows them to acts as a shared directory between the two containers. And so that's how static files get served within our Docker Compose setup. Thank you for watching. I've been Daniel Garcia with the Breeze Home 5.0 agent team. You can reach me at djarc287@fiu.edu. You can reach the product owner, Dr. Masood Sajati, at sajati@cs.fiu.edu.